And let's talk about it first. How will you address this problem? What would you do first? Say it again. Nope. I'm not saying no. I should say potentially. And then I'm going to ask you what you think I am going to do. So this is 15 on page 352, right? Okay, 1, 2, 3, 4, 5, 6, 7, 8 conditions. If you look at me, you'll see steam coming out of my ears. My head is exploding. If I don't summarize this information somehow, I will not know how to start. I'm looking at it and I have no idea which side to start with or which part to start with. So here's what I suggest. But I want you to think of each and every step and you tell me what to write. So this is my suggestion. If I don't summarize this information, I will not know what to do. Would you agree? You may say, I don't like your chart, I want to use my own. Please use your own. But summarize the information in a table. This is all over the place. I don't know where to start. Okay. Now I would like to identify the x values that mean anything to this problem. What are the x values that you will put in the table? Because you're not going to put 15. There's nothing about 15 here. So what numbers are important for this function? What x values are important for this function?
6.
Good. Another one. -2. Excellent. Another one. 9. Very good. Another one. Perfect. And one more. 12. Okay. And one more. So you said, did you say 0? Okay, you said 0. You said 1? I didn't hear anyone saying 1, I think.
Yeah.
Okay, so 0, -0, -2, 1, 9, 6, and 12. I want them in ascending order. Please give them to me in ascending order. -2. 0. 1. 6. 9, 12. Is that clear so far? Now I have to make sure that each and every piece of information fits in my chart. I can't leave anything behind. So I go back now to the first one. What does this mean? F of 0 is 0. This is my F. This is my 0. What do I write under 0? Good. So this is done. I'll come back. I should put this in right now. I was looking at the limit, but it doesn't matter. Okay. What does f prime of -2 equals 0 mean? F prime of -2 equals 0. F prime of 1. F prime of 1 equals 0. And f prime of 9 equals 0. Now this is done. Okay. Now I have limit of f of x, x approaches infinity is 0. Where does this fit? Right. What does that mean also? Very good. Y equals 0, horizontal asymptote. Are you with me so far? Is it clear what we're trying to do? We have to summarize the information. By looking at this, I will not be able to write anything or do anything. Okay. So now this is done. Limit of f of x as x approaches 6 from either side is -infinity. What does that mean? What does x equals 6 mean for the function in that case? If the limit from left and it's a vertical asymptote, which means nothing is defined there. If the function is not defined, nothing will be defined. I mean, the first, the second, blah, blah, blah. So then I have negative infinity here and negative infinity here. And this is done. Okay, now I'm reading this. What does this say to us? It gives us the sign of the first derivative, right? Okay, so between negative infinity and negative 2, what sign do I have to write for the first derivative? Negative. Between 1 and 6, what sign do I have to write for the derivative? And then for 9 to infinity, what sign do I have to write? Now this is done. Okay, now I'm told for the first derivative, between negative 2 and 1, what do I put? Between 6 and 9, what do I put? Now this is done. Okay, perfect. So now the second derivative. Between negative infinity and 0. What is the sign of the second derivative between negative infinity and 0? And between 12 and infinity. Now this is done. Finally, between 0 and 6, the second derivative is negative, and between 6 and 12. I'm not told anything about inflection points. I don't know points or anything. That's all I'm given. So I have, it's potentially 0, 0, an inflection point, right? That's what I see here. And 12, whatever, I'm not given the y value, inflection point, right? So I see here inflection point, but I'm not given the value, so another inflection point. Now let's analyze what this means. The derivative is 0, and the signs are negative and positive. So what will this be, which I don't have? So I'm free to do whatever with wherever how high and how low I want it. Yes, local min. Good. What about this and whatever? I am free to choose. What will 1 comma whatever be? And finally, what 9 comma whatever be? Again, local max. Now, do you see how important a summary, not necessarily mine, but a summary of the information given is how important it is? Now it makes sense. Now I know what to do with it. So let's give it a shot. I definitely know that x equals 6 is a vertical asymptote. I definitely know, I don't know on this side. I have no idea, but definitely on this side, there is a horizontal asymptote for sure. Yes?
Hypothetically, on an exam, if we have to sketch a graph, do we indicate like a horizontal asymptote of y equals 0, but just writing y equals 0?
That's fine. Yeah.
Okay.
Okay, very good. So then, at -2, I don't know how high or low. It opens upward at -2. Here, it's decreasing. Here is increasing towards 0, 0. So if it's increasing towards 0, 0, -2 should be somewhere here. So it opens upward, coming to a local minimum, and increasing towards the inflection point, which is 0, 0. Then it changes concavity, opening downward, but increasing towards 1 comma blah. I chose it up there. So it changes concavity, increasing towards this point, which is a local max. Then it starts decreasing on the left-hand side, opening downward, or the left-hand side of the vertical asymptotes, approaching -infinity. On the right-hand side, it has at 9 comma whatever, so it's coming from -infinity. So this is 6, 7, 8, 9, 10, 11, 12. At 9 comma blah, it has a local max coming from -infinity. So I'm going to say it's here. Coming from -infinity, approaching a local max. Opening downward. So it comes to 12 blah. I have no idea. I'm going to consider this. Where it changes concavity, opening upward and approaching 0. Can somebody come up with a different graph? Of course. But all these conditions have to be fulfilled. Any questions from me on this? Okay. I want us to go through all the steps of graphing for problem 22 on the same page. Any questions on this? Do we understand how this problem should be addressed? Okay. So let's look at one more graph. Y equals x over 1 minus x squared. I want you to work on this, please. Would you like me to line up the steps and we all do the steps at the same time? Or you want me to let you work on it for a few minutes? I'm sorry?
We'll give it a go.
Okay. Okay. Please. This is 22 on page 352. Let me know if you need help, please. You will have a problem on the test with all the graph. It's not going to be a super difficult problem, no. But you still have to show all steps. Okay?
Especially, I have a question about that. So the textbook shows us that you like always show symmetry. Do you want us to do that?
Yes.
Okay.
Yes.
Making sure.
Yes. Anyone needs help? Do we need more time? Okay. Can we start? Or not yet? Okay, how do I start? Exactly. What is the domain of this function? Very good. So in other words, you're saying x cannot be plus or minus 1. Do we all agree with that? Yes? Okay. So then at -1, the function and the derivatives don't exist. The function and the derivatives don't exist. Everyone is in agreement with this step? Yes? Okay, perfect. So now, when I plug in 0 in this function, what do I get? Yes, because it's 0 over 1. So that is the x-intercept and the y-intercept, and there is nothing else. We agree with that? Okay. Now, I need these. And I need to show what they are. Okay. So, limit as x approaches negative infinity from x over 1 minus x squared is what? Where does the top go? Where does the top go? Where does the bottom go? Good. How do I address this? Exactly. So this is limit as x approaches negative infinity. The top is, say it again. Excellent. Over. Good. Now again, where does this go?
0.
Exactly. So y equals 0, horizontal asymptote. Let's look at this. Limit as x approaches infinity from x over 1 minus x squared. Do you think it makes a difference? No, it does not make any difference. If it's negative infinity or positive infinity, the answer is still 0. Now I need these two and these two. Limit of x over 1 minus x squared as x approaches -1 from the left. Limit of x over 1 minus x squared as x approaches -1 from the right. Limit as x approaches 1 from the left. And limit as x approaches 1 from the right. As x approaches -1 from the left, the top is -1, and the denominator is 0. We know that. That's why those are vertical asymptotes. Okay, very good. So -1 from the left is like -1.1. Which of these two will be bigger? -1.1 squared is a positive number. Does that exceed 1? If it exceeds 1, then the denominator is negative. If this does not exceed 1, then the denominator is positive. It exceeds 1. It exceeds 1. So then here this is what? Very good. Okay, on the right-hand side of that asymptote, the numerator is still negative. The denominator is still 0. But now, -1 from the right-hand side is -0.9. 1 minus 0.9 squared. Is that positive or negative? That's all I care about. Positive. So then this is negative infinity. Now here, I know the top is positive and the bottom is 0 because at 1 is undefined. So 1 from the left, 0.9. 1 from the left, 0.9. The top is positive. 1 minus 0.9 squared. Will it exceed 1? Will it be positive or negative? Positive. And finally, positive at the top, 0 at the denominator, but 1.1. Which of these two, which will be the sign of the denominator? With 1 minus 1.1 squared. So this is negative infinity. And this is it. Is it clear how we determine the horizontal asymptote and how we determine the vertical, the limits left and right of the vertical asymptotes? And how we found the x and y intercept? Okay. Now, what happens if, for example, don't change anything? I'm going to erase it in a minute. And I'm going to choose a problem like this if we have time today or not, if not tomorrow. So now what happens if, of course I have to write x not equals 0, but now x will go away and I have only 1 at the top. Is x equals 0 a vertical asymptote? If the factor disappears, it's still a condition for the function. I cannot erase that. But since the factor disappears, is that a hole in the graph or a vertical asymptote? It's a hole in the graph because the factor went away. Okay? So that's not the case here.
Can you explain what you mean? It's like a jump?
Hole in the graph. An open point.
Oh, okay.
Yep. Okay, so we are done with this. Now I have to study the sign of, or study the first derivative, critical numbers, and so on and so forth. So I'm copying the function one more time here. What did you get for f prime? Can anyone give us f prime? The final form. Do we have the first derivative? Like this? Yes? Okay. Does anyone agree with this? I don't have it. We just picked the problem. I will have to work on it. But if you say it's okay and everyone agrees with it, I'll move on. Do we all agree with this? Please say yes or no. Yes? How many people did not get this? If you said that you didn't get it, I'll have to show it. Okay. Okay, so let's do that. So the top prime is 1 minus x squared times the bottom minus the top times the denominator prime, which is negative 2x, over 1 minus x squared squared. Is this clear? Top function prime is 1 times the denominator minus the top function times the denominator prime over the denominator squared. We agree? Okay, very good. So then 1 minus x squared, this indeed is positive 2x squared over 1 minus x squared squared, and that's perfect. X squared plus 1 over 1 minus x squared squared. Excellent. Let's look at this function and think whether this function can have vertical asymptotes, critical numbers coming from the f prime being undefined, where the function is defined. So this is undefined where the function is undefined, at positive and negative 1. So no critical numbers coming from f prime being undefined. Okay, now the question is this ever 0? No, because 1 plus x squared is never 0. X squared plus 1 is always a positive number, so it cannot equal 0. So then, can anyone establish the sign of this expression? Always positive. Okay, so I go back to my chart. And now I'm facing the moment of truth. If these two don't work together, I made a mistake somewhere. Okay, this is the moment in which I look carefully and look for mistakes. Okay, so from 0 to infinity, the function is definitely increasing. does the first derivative support that? The sign of the first derivative, yes. From negative infinity to 0, does the sign support that? From 0 to infinity, the sign supports that? And from negative infinity to 0, the sign supports that? Okay. So, are you okay?
Yeah.
So now for symmetry, we have to show or find f of negative x, which is negative x over 1 minus x squared, because x squared does not change, which is the same thing with negative x over 1 minus x squared, or the opposite of f of x, because this is f of x. What type of function has this property of f of negative x is the opposite of f of x? It's an odd function. Very good. Which is symmetric with respect to the origin. Origin. Perfect. Okay. So my last step, I have to differentiate this. Ready? To find the second derivative. The top function prime, 2x, times the denominator, minus the top function times the denominator prime, 1 minus x squared times negative 2x, divided by 1 minus x squared to the 4th. Let's do this one more time. The top function prime is here. Oops. Times the denominator, minus the top function times the denominator prime, 2 times 1 minus x squared to 2 minus 1 times the inner function prime, which is negative 2x. Is that okay? Okay. What do you think I am going to do next? Absolutely. This and something from here. So definitely a 2x and definitely a 1 minus x squared. I can't handle this if I don't factor it. I won't be able to solve it. I shouldn't say I won't be able to, but it will take like forever. So yes, from here, a 1 minus x squared is left. Now remember, this is minus and this is minus. So it will change into plus. 2x from here is out and this is out. All I have to do is distribute here. 2 minus 2x squared. One more time. 2x and 1 minus x squared are common to both. 2x is outside, one of these is outside. So from this, I am left with 1 minus x squared. Because these two are negative, this sign will change into positive. This is out, this is out. So 2 times 1 and 2 times negative x squared. Is this okay? Yes. Thomas, go ahead.
You're supposed to factor out the 2 into x squared plus 1, not the 1 minus x squared.
Oops. Thank you. Good point. Yep. Thank you.
We've got negative, it's not the same thing.
Well, it's canceled out.
No, this negative with negative will go away. So careful. So this is out. This is out. So I have 2x squared and plus. Okay, thank you. So it's 2 times x squared and 2 times 1. Thank you very much. I put this the arc on top of the wrong factor. Thank you. My mistake. Sorry about that. And yes, we would have caught the mistake, but I would have panicked. Why? I can see that. Who knows? Thank you. You saved me. Oh, I should have simplified. Okay, so then 3 minus, so plus x squared. So I have a 3 and I have plus x squared. Good, excellent. So the simplified form is 2x, x squared plus 3, 1 minus x squared cubed. Now, I would do this. And you'll tell me why I'm doing it. So I don't have to worry about that. Okay, so when the second derivative is 0, the top could be 0, but this cannot be 0. This cannot be 0. So the only one that can be 0 is this. So x equals 0. And we'll see if this turns into an inflection point in a second. Okay, so this is all positive. So I'm studying the sign of x over 1 minus x squared. X over 1 minus x squared. So I'm going to plug in a number like -2. -2, this is negative. -2 squared will be 4. 1 minus 4 will be negative. Negative over negative is positive. I will plug in negative 0.5. Negative 0.5. But negative 0.5 squared is 0.25, and 1 minus 0.25 is positive. With 0.25, this will be positive, and 0.25 positive, so this will be positive. Finally, I plug in 10. Positive, but negative. According to this, 0, 0 is definitely an inflection point. That's all we need. All we worked was for this chart, to fill up this chart. Once we filled it up, including the symmetry, I'm done. I can graph it. Okay, here's the graph. When I graph a function with asymptotes, I have to start by graphing the asymptotes first. So at -1, at +1, so I should have written here x equals -1 is a VA, and x equals 1 is a VA. And the horizontal asymptote, y equals 0, x equals -1, and x equals 1. The only point I see is 0, 0. So, from the horizontal asymptote, from approaching 0, it's increasing to positive infinity on the left-hand side of the first asymptote, opening upward. In the middle, opening downward. From negative infinity, increasing to the inflection point. It changes concavity, still increasing, opening upward towards infinity. Finally, from negative infinity, increasing to 0, opening downward. And this is the graph of f of x equals x over 1 minus x squared. We were able to do everything in pre-calculus, except the inflection point. Okay, so this type of function, we were able to study it, but not in this detail, not with limits, left and right, but we were just plugging in numbers, but we were not able to write limits. We did not have the limit operator at that time. Okay, I'd like to look at a couple of limits. We have about 7 minutes left, so would you like Rolle's theorem, mean value theorem, or some limits? That's what we have time for today. Limits? Very good. So please choose 7 through 14 on page 352. 7 through 14 on 352. Anything you like. Which one? 12. Let's start with 12. I'm hoping to see you tomorrow at 4:30 in this room to continue reviewing for this test. Okay. Limit. So x approaches pi from the left. X minus pi cosecant x. Okay. So you want to think about it for 20 seconds, 30 seconds, or say it again? Okay. What do I have to do first? Where does this go? Perfect. Where does this go? Before you answer, just remember what is cosecant. We normally don't like to think in terms of secant and cosecant. We like to think in terms of simple, which is sine cosine. So what does cosecant x equal to? It cannot be c and c. It's the other one, yes. So if this is c, this is s. If this is s, this is c. Okay, perfect. So pi from the left. This is pi, and this is pi from the left, with angles smaller than pi. Okay, so how much is sine at pi? Sine is measured on the y-axis. So I'm really asking you at pi, how high is that point? 0. So if this approaches 0, now you will tell me what does cosecant approach. If the denominator approaches 0, what does cosecant, which is 1 over 0, approach? True, but it's from the left. Right. What kind of indeterminate case is this? Right. Can I use L'Hopital's rule on it? I can only use L'Hopital's rule on 2, and only on 2. 0 over 0, or? Right. I cannot use L'Hopital's rule on 0 times infinity. But I'm hoping something. What am I hoping for? I'm hoping that I can change 0 over 0 times infinity into, or, exactly. Yes.
Wait, never mind. Sorry, I was gonna ask something that you just said, just in a different way.
Okay, good. So, what would you do? How will you continue with this? Which of these two functions will you work on? I already have the ratio. If I bring x minus pi as 1 over x minus pi to the denominator, then I have a ratio to differentiate. I don't want to differentiate the ratio. Is that clear? So what will you write? Dictate and I will write it. So since cosecant is 1 over sine, x minus pi over 1 times 1 over times 1 over sine is that. Let's plug it in again. What does this? Where does the top go? Where does the bottom go? I'm done, right? By a simple algebraic manipulation, I change 0 times infinity into 0 over 0, and now my hands were tied here, but now my hands are not tied. What do I mean by that? So x approaches pi from the left. What is the top? What is the bottom?
Cosine.
Very good. Good. So now, as x approaches pi with angles smaller than pi, cosine approaches. Cosine approaches. Cosine is measured on the x-axis. -1, yes. So this approaches -1 right here. This is cosine, -1. So when x approaches pi with angles smaller than pi, cosine approaches -1. So the answer is -1. We have time for another limit. Please choose. Let's do 14. Did you have something else in mind?
Not
14.
14.
So we have limit as x approaches pi over 2 from the left of tangent x raised to cosine x. We're asked to find this limit. What will I have to do first? Yes, yes. So as x approaches, this is pi over 2. As x approaches pi over 2 with angles smaller than pi over 2, what happens to tangent? Where does tangent go? We don't have to think in terms of tangent if you don't want to, or you can think in terms of a graph, but also you can think in terms of sine x over cosine x. Where does sine go? Very good. Where does cosine go at pi over 2? How much? Perfect. So then tangent will approach, yes, indeed, infinity. Okay, what about cosine? So this is 0 times infinity. I should have boxed it in for everyone to see. So where does cosine go? Yes, cosine goes to 0. This is one of the most difficult situations to work with. Right? It's kind of difficult to change that into what will I want to change it into? Even infinity over infinity or?
0.
Right. This is one of the most difficult situations. Okay. So I go back. I have tangent raised to cosine. What do I have to do? Exactly. It's that situation in which I have a function raised to a function. Somehow I have to bring that function down. Yes. So I'm going to say let y be tangent x raised to cosine x. And yes, natural log y equals cosine x times natural log tangent x. Okay, what do I think of doing next? Okay, I changed the function, basically. I was really asked to find limit of tangent raised to cosine, and I said no. I'm going to apply tangent, I'm going to apply the log, and I'm going to change the function. I changed the function. I'm no longer looking at tangent raised to cosine. What do I do now? I can't, unless it's a limit. I can all of a sudden say, hey, I'm going to take the derivative. I cannot do that. It's the same problem. Oh, absolutely, but I had to change the function. I had no choice. I have to take the limit. So right now I only change the function, and now I will find the limit of this new function. Although this is not the original function, I have no choice. So now I have to apply the limit to the natural log y when x approaches pi over 2 from the left. I have to write limit as x approaches pi over 2 from the left of cosine x times natural log of tangent x. Now I have to see what this is all about. So one more time, I could not determine the limit of the function I was given. So now, in other words, I'm doing this. So I start with something else, I apply natural log, I find that limit in the hope that I come back to find the limit that I'm interested in. Only because I have this situation which is not friendly at all, a function raised to a function. So I created a new function, which is this, and now I'm finding the limit of this, but I have to see what that means. So now, one more time, as x approaches pi over 2 from the left, where does cosine go? That didn't change, 0. Now tangent did not change, so when x approaches pi over 2 from the left, tangent still approaches infinity. But what does natural log of infinity mean? Where does this go? Remember the graph of natural log. As x approaches infinity, natural log goes to infinity. So now I changed that very difficult situation that I started with into a much more relaxed product, from a power indeterminate situation into a product. This, I know it's not that hard. It only needs a little or a small algebraic manipulation. So let's see how we do that. I need an algebraic manipulation from you that will change this 0 times infinity into either 0 over 0 or infinity over infinity. Which of these two functions will you manipulate?
Natural.
I can't. If I bring 1 over, no, I can't. This is together. I cannot separate that. It's either this, which is approaching 0, or this. I cannot touch anything inside of log. Okay? So if I bring natural log to the denominator as 1 over, I'm never going to solve. So this is not the key. This has to stay as is. So the other one will be changed into 1 over cosine. So I have natural log tangent x 1 over cosine x. Is this the same thing? Yes. When I divide this by 1 over cosine, I get this. But now I have to replace 1 over cosine by what? Because I don't want to differentiate a ratio. Oh no. So this is very good. Natural log of tangent x over secant x. Okay. Now I try again. Well, I know the top goes to infinity. But where does the denominator go? So if cosine goes to 0, then 1 over cosine will go to right. Finally. Look how many steps I had to go through. I know, I exceeded, so I'm going to stop. But we can finish it next time, or you can finish it. So I had this. I changed it into this. And now I finally have infinity over infinity. And then what will you do afterwards? So I would like you to finish it, because I